Hi, I'm Anant Chaudhary from John F. Kennedy Middle School, and today we're going to continue on of last time's discussion on the Cartesian coordinate system and move on to the length of the line. So let's get started. So just a reminder, a line is basically the distance between two coordinates, and that's called a line. So this coordinate I'm going to call x1, y1, and this coordinate I'm going to call x2, y2. So basically, first thing we want to do is we want to find the distance of the y's. So if I drop down from this point here, I have this line, and this is the length y1. And if I drop down from this point to the origin, it's y2. So it's y2. And if I were to draw that right here, this is y2. So this is y1, this is y2. If we want to find the total distance of this line, it's going to be y2 minus y1, just to find this distance here. Okay. Now, if we want to find this x distance that I drew earlier, this x line I drew here, we have to find out the distance from the point to the y-axis. So what we're going to do there, it's going to be x1 is going to be from here to here. So this whole value, including a little extra part here, is going to be x1, and this little part here is going to be x2. So the same logic we had here, it's going to be, just to find this total value, it's going to be x2, or x1, it doesn't matter which order, x1 minus x2. This is the way you find these lengths. Now, as you can see, we kind of formed a triangle here, and we have two of the given sides, and we have one side remaining. And this might be familiar. It's called the Pythagorean Theorem, and this is where our formula is derived from. So we can say this now. PQ, if I was just to give these coordinates a name, PQ squared is equal to y2 minus y1 whole squared plus x1 minus x2 whole squared. Now, if we want to get this square removed, then it's just going to be PQ is equal to the square root of y2 minus y1 whole squared plus x1 minus x2 whole squared. So now let's just do some sample problems. So if we were given the two coordinates, perhaps 4, 7 and 9, 6, perhaps, we could just plug these into the formula. So PQ is equal to y2 minus y1 squared plus x1 minus x2 squared. So I can say, just for now, this is x1, this is x2, and this is y1, this is y2. Just pointing that out there, okay? So the first part says that it's going to be y2 minus y1, or it could just be y1 minus y2. It doesn't really matter, but it'll be 7 minus 6 whole squared plus x1 or 2 minus x1. So it'll be 4 minus 9 whole squared. 4 minus 9 whole squared. Now if we continue and simplify this, PQ is equal to square root of 1 plus the square root of 25, and at the end this is equal to square root of 26. Now this is just one example. You can use this for any line possible, and some other things you could possibly use this for is to find out what type of triangle is given. So if I were to give you this random triangle with P, Q, R, and I ask you what type of triangle it is, you could find the measurements of the line by finding the length of PQ, finding the length of QR, and finding the length of PR. So if these two lengths are the same, as we know, it'll be isosceles. If all lengths are the same, it's equilateral. And if none of the lengths are the same, it's an isosceles. Or if it's like up here, it'll be a right angle triangle, and that is one of the uses for this formula. So I hope this video came to some use for you, and I'll see you guys next time. Bye.